A very good evening, everyone. The week 8 of the Crystal Symmetry and Tensor course has been over, and there we have discussed a lot of interesting topic about the point groups. Okay, so this is a doubt solving session where we will discuss few questions based on those, the concept which we have learned. Okay, so let me share my screen. Yeah, so the topic which are covered in this particular week are as follows. In this particular week, we have devoted this entire week to the 3D point group, where we discuss first about the proper monoaxial point group, which are the 1, 2, 3, 4, and 6. These are the proper monoaxial point group. Proper means they are not going to change the handedness. Then again, we discuss about the dihedral group. These are again the proper one only. So there we have discussed about the 2, 2, 2, 3, 2, 4, 2, 2, and 6, 2, 2. Okay. After that, after this, we discuss about the proper cubic point group, which are 2, 3, and 4, 3, 2. And with that, all this 11 proper point group is been over. Then the turns of the improper point group, which was consisting of the 1 bar, 2 bar, 3 bar, 4 bar, and 6 bar. Okay. After that, we combine the mirror and the enfold. And the mirror was passing through the enfold. In this case, mirror is passing through the enfold. So there we discuss about the now what we have got, the list of the point group mm2, 3m, 4 and 6 So these are the list of the group which we have got in this particular case. Case 2. Combination of the mirror passing through the enfold. Then there was a set where we discuss about the mirror perpendicular to the enfold. That is 2 over m, 3 over m, 4 over m, and 6 over m. Out of that, this has already been covered as a 6 bar. So this is just a repetition, so we'll not include that. So with that, if we count, it will be total of 12 improper point group that has been discussed. There are few more left which will be discussed in the week 9. So for a time being, this thing which we have discussed about remaining part. So out of 32, 11 are the proper and remaining so let me read it for you. It might not be visible. Yeah. So the type 1 operation in the point group 6 bar. So we need to write the type 1 operation which is in the 6 bar. See, this entire thing is already been covered by the profession. So if you once like if you have already watched, then it is very extremely easy for you since it is just a repetition. So let's start with the one of the point, and we are going for the 6 bar. Okay, so this is the first point. How we will get the first point itself? Uh, that is by the one complete 360-degree rotation, trivial fold. From here, we'll rotate by 60 degree and then we will invert it. Okay, so we'll get somewhere over here. Considering this point, we'll go with the 60 degree and then we'll again invert it. So we'll get, since this was below, it will come over here above. Again, rotate by 60 degree, invert it, you will get it over here. And in the similar manner, you can get the entire thing, something like this. So how about this? How we can write these particular points? So they are talking about the type 1 operations. Type 1 means proper. Look at the option C. It is having the 6 bar. That is the inversion. So this itself won't be, we can directly eliminate the option C since it is having the 6 bar to it. Again for the option D also we can eliminate all of them. Now what about A and B? They all of them are having the proper only because 1 and 3 fold. 1 fold, 3 fold in the clockwise, sorry, in the anti-clockwise, and then 3 fold in the clockwise. So all of them are proper. Now we need to know like which of them is correct or are. Okay. So let's write the, so first point we will get it by 1 bar. Second point, if we only talk about the dot, we will get it by 3 plus. Sorry, not 1 bar. We will get first point by 1 fold rotation. Second point we will get it by 3 fold rotation in the clockwise, in the anti-clockwise manner. Third point, this, the point which is above, we'll use this for the above and we'll use this for the below point. That we will get it by 3 bar. Right. Remaining point one can also get like this hollow one. This hollow one, how we will get? We'll have to just take a mirror of the first point. Considering the first point, this is the first point. We'll take a mirror. Mirror will be along this entire plane, and we'll get M. And remaining part we will get, if we want hollow this point, starting from the first point, we have to rotate by 60 degree in the anti-clockwise manner. Then we have to invert it. That is 6 plus bar. Similar manner, one can get the another point at 6 minus bar. So these are the set of the symmetry operations. But they are only asking for the type 1. So type 1 include 1, 3 plus and 3 minus. So that is option 2. Option B is a correct option. Also option 1 itself is a, that is also a correct option. So in question number 2, we have to write a correct point group for the stereogram shown below. You will find couple of questions like this in your assignment, week 8 assignment. The question is telling that we have to write a correct point group. We have to write a point group. So point group is missing over here. The stereogram has been given to us. Okay. So let's analyze this particular stereogram. Considering this map to be the initial point, how can I get the another this dot which is above the plane? I just have to do a four-fold rotation. So I got to know that okay, there is a four-fold rotation which will rotate this point 1 to the point 2, point 2, point 3, and point 3 to the point 4. Okay, but then how I will get another remaining points, these points? One just have to analyze it properly. We can see that if I take two-fold about this particular point, about this, about this exit, if I take two-fold, what I will get, the first point will be converted to this particular point number 5. Point number 3 will get to over here, two-fold. Point number 2 will get to over here, 6. 3 will get to over here, 7, and 4 will get to over 8. So what we are saying, there is a two-fold is there, and there is a four-fold is also there, right? So this is a combination of the two-fold and four-fold. So we can say that yeah, it is a dihedral line. So two proper axes, which is a 4 and 2. Two proper axes, that is a 4 and 2. They are in the combination over here. So what this particular group will be 4, 2, 2. Why this additional 2? We have already known that from the class that along with this particular mirrors, along with this particular two folds, this set of two folds, we are generating additional two folds, which is over here. And just seeing the stereogram, we are able to analyze what is its point group. How do we write? This is the international notation, right? Herman Moger notation. How do we write about the so inverse notation? So that is given as D. So now let's get to the question number 3. So question number 3, what question is 3 is telling that we have to write a type 2 operation in the 4 point group. So 4 point group is given to us. And we have to write type 2 operation. This is missing. Okay. So let's make the 4 point group and see what order it is having, how many symmetry operation it will be having with itself. Okay. We'll do it very quickly because this thing has been covered in the class, in the online lecture. Oh, anyway, we can assume that it is a slice in the proper manner. I did little bit below. 4 is given to us. Okay. Mirror is written adjacent to the fourfold. It means that mirror is vertical mirror. If it has been horizontal mirror, then it should be written like 4 over m, which is not the case. So here the mirror will be perpendicular to fourfold. Okay, but in our case, it is not the case. It is not given. Mirror is vertical, which is along the fourfold. So let us say this is our fourfold. And consider this particular axis to be mirror. Mirror is passing through this. Vertically it is slicing our plane. Start with the first point. First we will do the fourfold of rotation. This is what we have got. Now we have to apply the mirror to it. Right. So how many points we have got? We have got total of 4 points till now. Let's also write its how we can denote this. So first point we will directly get by one fold of rotation. Point number two we'll get by the fourfold, 4 plus. Second we will get it by 180-degree rotation, that is a twofold. And third point, sorry, the fourth point we will get it by 4 bar. Sorry, 4 inverse, 4 minus. Now we are applying the mirror to it. Let's apply the mirror and see. 1 will get over here, point number 5. 2 will get over here, 6. 4 will get to here, 7. And oh, 7, and this will be 8. Now we can see that these are the by default generated mirror. In the class it has been discussed that we will get few additional mirror along with this, which we can see ourselves. Right. So other than this 4, the red points we have to mark. We have to write the symmetry operation for them. So now let us say this is O1 O direction, and this below direction is a 1 O direction. Okay. So our point 5 we will get the point 5 by 1 if we take a mirror, this this mirror which is perpendicular to the O1 O direction. So we can write M O1 O. We will get this 7 from the point number 1 to 7 by this particular mirror, horizontal, this particular mirror, which is perpendicular to the 1 right. Now how we will get point number 6? We will get this by this particular mirror. This particular mirror is perpendicular to the this particular direction, which is the 1 1 0. So mirror along 1 1 0, and remaining points, point number 2, we will get along this particular mirror which is perpendicular to this particular direction, and this direction is nothing but this direction we have to find. This we have already known, 1 0 0. This is O1 O, then it will be O1 bar O, and this will be 1 bar. So mirror will be along the 1 bar. And with that, we have completed the symmetry operation, set of symmetry operation. Let me bracket them. So the question is not asking about the symmetry operation. They are very specific about the particular operation. They want only type 2. In question number 4, we have to write a correct point group for the stereogram given below. It is something like question number 2. So again, what is the missing is a point group. Okay, stereogram has been given to us and we need to find the point group. Let's start with the considering this to be the point. Since this is a slice in a 120-degree way, or one can say that okay, a 60-degree, after every 60-degree we are slicing it. Let's try to rotate this first point by 60 or 120 and see where it is going. If I rotate it by 60-degree, I am not getting anything. Let's rotate it by 120-degree. I got one point over here. Let's again rotate it by 120 and I got one more point over here. Again I rotated by 120-degree, I got over here. Okay, so somewhat I'm seeing that okay, a threefold is there in it. Now, how about the other point? How we can produce the other point if we consider this to be the threefold for a time being? Since all the points are above the plane, we will use this for the above the plane and this for below the plane. So all of them are above the plane. It means the center of inversion is not there. Twofold is also not there because if it has been twofold, then if we consider this to be the twofold, then point should go below, which is not the case. So this is also not there. So what we can see that if we apply the mirror, let us say this is our mirror, then point number 1 will get to the point number 2. This sorry, this is the 2, this is 3. Then point number 1 will get to the point number 4. 2 will get to this, and 3 will get to this particular point 6. So we can map all of them. So that's how we can see that okay, yeah, it is a combination of the threefold and mirror. And mirror is also in such a way that it is a vertical mirror. It is not a horizontal mirror. It is a vertical mirror. Okay. So how we can write that in this particular point group? It will be 3m. Right. So that's how we have found this. And with that, question number 4 is over. Along with that, we can see that these are the by default generated mirror. They will be, but they are obviously they are of the same kind, like they are the same nature. If I rotate the first mirror by 120 degree, I will get the second mirror. Okay, so we have to verify something here. Verify that resulting symmetry operation for this is this. You will find one question something like this in the assignment. So let me write the what we have to prove first. Threefold rotation 111. So this is equivalent to the 2 plus O 1 O. Whether it's 2 plus or 2 minus, it shouldn't matter. I shouldn't have write this also. Okay, so better we can neglect this. So the threefold of rotation about 111, which is followed by threefold of rotation about 1 bar 1 1. Okay, 1 bar 1 1 and 1 1. It is resulting in the twofold O1O. This is something which we need to prove. Okay, so let's start with this and followed by this. So first we will apply this particular operation. Consider the axis of cube. This is x, this is y, and this is z. If about this particular axis, which is 111, it will go like this. I have to apply the threefold of rotation. What will happen? After threefold of rotation, x, y, and z, they will change their position. So this was initial. Finally, they will be get to the point. This will be the x, this will be y, and this will be z. So x has changed to the y, y changed to the z, and z changed to the x. Let's write symmetry transformation matrix for this. So x has changed to the y. So how we will write x? O 1 O. Y has changed to the z. How we will write? O O 1. And z changed to the x. We will write it 1 O. So this is for the first operation. Now let's see think about the second operation. 1 bar 1 1. Now let's think about the 1 bar 1 1. Let me make a cube first. Okay. So how first we have to look at this particular direction 1 bar 1 1. X is in the negative, so we will go we will uh, fix our origin over here so that we can go to the negative of x. Y is positive, sorry, y is positive, and z is also positive. So we'll get to this particular point. So and this is our direction. And since the sense of rotation is plus, that is in the anti-clockwise manner. Here also we have follow the anti-clockwise only. and from here also we will follow the anti-clockwise. So what we can see, this is our x, this is y, and this is it. Now let's see from this particular angle what we will get. We are getting y, we can see y, we can see z, and instead of writing x, let's write, go to the another direction, which will be the minus of x. Now about this, there is a this particular direction, one bar, one. Now we have to rotate it in an anti-clockwise manner. Now z will change to the minus of x. Z is going to take the position of minus of x. Minus of x going to take the position of the z, and z will change. Oh, see, y will take the position of minus of x. Minus of x will take the position of the z, and z will take the position of the y. I wrote right, but pronounced it wrong. Okay. So now let's write the symmetry transformation matrix for this particular operation. So what and all are happening over here? For 3, 1 bar 1 1 in the positive sense, y is changing to the minus of x. So we will write minus of 1. O, O. Minus of x has changed to the z. So x minus of x has changed to the z. It means that x has changed to the minus of z. So we will write O, O minus of 1. And z has changed to the y. So we will write O, 1. And with that, we have got two operations. Symmetry transformation matrix of 3 plus, which is 1 1 1, and 3 plus, which is 1 bar 1 1. All we need to do, we need to multiply them. Okay, so let me write over here itself and we'll multiply it. Now we need to do a simple matrix multiplication. Let's do it. First row, first column, we will get minus of minus 1. First row, second column, 0. First row, third column, 0. Second row, first column, 0. Second row, second column will get 1. Yeah, we'll get 1. Second row, third column, we are getting 0. Third row, first column, 0. Third row, second column, again 0. And third row, first column, sorry, third row, third column, minus 1. So what we are seeing that the final, this particular symmetry transformation matrix we are getting. What this mean? It means that O1O, that is y, is at the position of y itself. X has changed to the minus of x. And z has changed to the minus of z. How can this happen? How is it possible? Okay. So this is x, this is y, and this is z. So x need to change to the minus of x. That is a transformation by 180 degree. Yeah. So here we are. A simple question. I hope it is visible. Let me write C6V, C6, C6H, C3H. And this is 6 over M, 6 mm, 6 bar, and 6. So we need to match international table notation. Sorry, international notation with the so in flash notation. We'll start with the easiest one, that is 6. And we know this is a cyclic group. It will be matched with the C6 itself. Right. So 1, 2, 3, 4, and 6. In the international table, in the international notation, it is written like this. In the Swain flash, it will be C1, C2, C3, C4, and C6. And that's how we can write them. What about the 6 bar? See, if someone is remembering that, okay, yes, I know answer of this, how then I can directly click, I can directly match it. But what about if someone is not remembering? Okay, what to do in that particular case? Take a stereogram, draw it, draw your 6 bar, you will get something like this. And this you can see that, okay, yeah, it is a threefold rotation, which and a mirror which is along the which is horizontal mirror. If I take the horizontal mirror, these particular points will be converted to the circles. Above will go below. So this is a cyclic group, six threefold rotation by six threefold only, and it will be horizontal mirror. So it will match with the three C3H. Okay. Now, in the similar manner, one can perform for the remaining two, 6 mm and 6 over m. Let's talk about the 6 over m. Let's draw its stereogram. So what we need to do, we need to take a 6 fold and then mirror it. We have to mirror it. Let's start with the point. Rotate it by 60 degree. Rotate by 60 degree. And then take a mirror of it. Mirror is in the perpendicular. Okay, it is mentioned that this is a perpendicular mirror. So this is a fold of rotation 6 fold. So along with this particular fold, there is a mirror. Like perpendicular to this particular fold, 6 fold, there is a mirror. Okay. So we can say that, yeah, this itself is a mirror. And once we apply that, what we will get? this point. Okay, so this is a cyclic, six fold is there, and perpendicular mirror are there, that is a horizontal mirror, right? So C 6H. So we can match this with C 6H. One itself is remaining, only one of them are remaining. We can directly do that, but still, for the sake of completeness, let's 6 mm we will draw. So start with the 6 fold. First point will, no, again this is a, it's not the vertical mirror. Sorry, it's not a perpendicular mirror. It's a vertical mirror itself. So it is along the fold of rotation. So along this further fold, we can take a mirror. Let us say that this is our mirror. So what we will get? We'll get this point over here, this point over here, so on and so forth. This question itself has been discussed by the Professor Rajesh Prasad, and we'll just revise it and we'll just complete this extremely fast. We'll solve this question. Okay. So what the question is, really we have to write order. We have to write the order. Okay. And the symmetry operation. Two things we have to do. For the point group, this we have to do for both the point group 3 2 and 2 3. So we know 3 2. 3 2 is a dihedral. And we know 2 3. 2 3 is a proper cubic point group. Okay. So let's to in order to write the order and symmetry operation, we must have to draw the stereogram of that. Let's start with the first one. We will start with a 3 2. Okay, so we have threefold and twofold. Threefold, we usually combine threefold and twofold in this particular manner itself. All the diedrals will combine it like this. Okay, so let's take a threefold first. Starting with this particular point, we'll get over here, and then we'll get over here. Now let's take a twofold. Twofold along this. So we'll get this point over here. It was above, then it will go below. So if you are taking something and rotating it by 180 degree, entire this point will go below. Which was above to you. After 120 degree rotation, it will go below, irrespective whether you rotate it by clockwise or anti-clockwise. Again, this point will come over here, and this point will come over here. Okay, similar to this, we have generated the additional mirror, which was expected to generate. Okay, so total of we have generated in total 6 point groups. Sorry, 6 points. Starting with the one general point, we have generated total of 6. Now we have to write the symmetry operation for them. So first let's write for the this threefold rotation, the red one. So first point I will get it by point number 1, I will get it by one fold of rotation. Point number 2, I will get it by threefold of rotation in the anti-clockwise manner. And point number 3, I will get it by threefold of rotation in the clockwise manner. 3 minus. Now, what is remaining is this. Point number 4, 5, and 6. So point number 4, how one can get it is a rotation about this particular point, this particular axis. We have to denote the notation for them. Let us say this is this direction is 100, and this is 010. So we will get this particular direction as 110. So for the point 4, if I want to get point 4 from point 1, I have to rotate it by twofold about 100. How can I get point number 5 from this particular point number 1? I have to rotate it by this particular axis 110 by twofold. And in order to get this particular point, point number 6, we have to rotate it by about this particular axis 010. Sorry, the second one was 2110. And with that we have seen that okay, it has the order of 6, and we have brought all the symmetry operation to it. So the first part is done. That is a 3 2. The dihedral one. Now we have to write for the 2 3. For the point group 2 3. So considering a cube, see this has already been done. We'll just wrap it up fast. Considering cube, this is a tetrahedral one. Okay, so there is only two-fold and three-fold is present. So if I select these particular points, I can make a tetrahedral. And about this particular axis, there is a two-fold. About all the axis, there will be a two-fold. About this particular. Okay, along this, and along this also. So we are having over total of three two-folds, and we have the threefold also. Threefold will pass through all this particular point, and let us say one of the vertex of the tetrahedron and opposite face. Okay, in the similar manner, one can say that okay, if this is a vertex, there is another opposite face. Considering this to be the vertex, there will be another face. So total we are having the 4 points, four vertices, and there will be the four threefolds. Okay, so let's by default take one of the point as a trivial point. So twofold will additionally generate since one is already been done. So twofold is known to generate 2 points, right? But one is already been considered in all the cases, so that there shouldn't be any overlaps with each other. So there are three folds, three two folds. We will get total of 3 points, one corresponding to each of the folds. Similarly, for the three fold generate total of 3 points. One threefold generate total of 3 points. Considering the first one trivial one, okay. So let's remove that which we have already included. So this will generate total of 2. So 4 to that it will generate total of 8. So this is 11 plus 1 we will get 12 of those points. Now if we have to write the symmetry operation for them. Okay. So if we have to write the symmetry operation all 12, we have to write what is an angle between the two consecutive two folds in 6, 2, 2. So we have to draw the 6, 2, 2 first. We have to find the angle between the two consecutive two fold in that. Okay. Start with the six fold is there. Okay. So okay, let's mark the six fold. Two fold is there, and it is uh, written adjacent to the six. So we can say that okay, it is a combination. So we usually consider this two fold. Let's start with the six fold. First point, we'll get this particular point. Now let's apply the two fold to it. What we will get? This point will get to hollow, like it will go below. Same will happen with this. So we can see we have generated the few additional two folds, which are first one was this. Okay. Additionally generated by default generated are this one. And the way the symmetry are, we have generated few more. These two folds. Okay. And so we can see that this is one mirror and this is another mirror. Consecutive mirror we have got. All we need to do, we need to find the angle between them. This entire is 120. Half of that is 60 and half of that is 30. So we can see that the angle between the two consecutive mirror in 6 to 2 is 30. That is option A. And with that, we have solved all the questions based on the week 8 content that has been discussed in the online lectures. Okay, so you will find assignment question to be very easy, and once you go with the entire video of the Professor Rajesh Prasad week 8 content and this particular doubt solving session, and you will be easily will be able to solve those questions. Okay, so with that, let's wind up the today's lecture, and we can meet in the next upcoming doubt solving session.